Hello dear viewers.
Welcome back to Grieve Makes.
This is Phineas Gage, or more specifically, a 3D print of his skull. Today we have a guest voice, my wife-to-be, Harri. She studied psychology at university and is here to tell us more about Phineas Gage.
Phineas Gage was a railway worker from the USA, born in 1823. On the 13th of September 1848, an explosion caused a metal rod to enter his face, under his eye and exit through the top of his head. He miraculously survived with severe injuries. Most notably, almost all of his left frontal lobe was destroyed. He lived another 12 years after the incident, with friends and family noting the profound impact the injury had on his behaviour and personality. He is talked about to this day as a fascinating psychological and neurological case study and influenced a lot of discussion about the mind and the brain in the 19th century and beyond.
The model of Phineas's skull is freely available to download on Thingiverse, so I'll put a link in the description. And I printed it using a Formlabs Fuse 1 Plus SLS 3D printer, and it's printed in Nylon. I printed it for Harri when she was teaching the subject of psychology. For this skull I wanted to design a simple stand so it can be displayed nicely in our home. To each their own, I guess. I'm going to utilise STL mesh editing in Fusion 360 to ensure I create a stand that holds the skull and at the same time shows a representation of the rod that changed his life forever. Let's get started. So I brought the skull into Fusion 360 and the first thing I'm going to do is play around with the orientation of the skull. I want it to look good when it's displayed, but also, my goal is to demonstrate the injury that actually caused this to happen. You can see that looking at it from a certain angle, we actually can see all the way through the skull in a straight line, but unfortunately in this case it doesn't actually line up vertically on the Z-axis. I'm just now playing around and just taking some time to sort of adjust it by, minor increments to make sure that when I'm looking at it from the top plane, so on the Z-axis, so I can see a straight line through the injury. Looking at it from the bottom, you can see the same thing. I can see straight through the injury right on that flat bottom plane. And now I'm just putting a circle in that injury hole, kind of gross to say, that is roughly the right size. I'm now moving the skull down, so it's only sort of 5mm or so from the base plane. I can extrude that rod all the way through, and this can form the basis of the stand. I'm just placing the circle in a rough position here. I'm not trying to be too specific, but I want to basically ensure that I have a good flat base so that the skull isn't going to tip over, but also one that's not too massive and overbearing. And you can sort of see that, looking at it from different angles, that the skull is roughly in the centre of that circle. Adding a little chamfer to the top to make it easier to put the skull over, and then I'm adding a chamfer to the bottom to increase that contact area to make sure that the rod is nice and strong. Now, some people would say that it's probably best to use like an actual wooden rod or something of a different material. A lot of cases when it comes to using hardware instead of 3D printing it, that is the best idea. But in this case, I just wanted to print the whole thing and see how it came out. I've added now a pillar for the back of the skull because I want a nice area for the skull to rest on that is perfectly contoured to the shape of the skull. I'm using two planes now that are either side of that base to cut the skull in two different places. What I'm going to need to do is convert this STL mesh into a solid editable body, and this is very, very demanding on computer resources. By cutting the skull up a little bit, I'm actually creating a smaller mesh area that I can convert, as you can see here, and this effectively means that the conversion of this small area that is actually going to be converted into a solid body is going to be much less demanding on the PC. What I'm doing here is I'm actually excluding some specific cut out areas of the skull, and the reason for this is because when I convert the little section of skull into a solid body, I'm going to do a cut with the section of skull with this pillar. And this is going to be great, but the downside is that all these little holes that are in the base of the skull are going to mean that the material is effectively locked in. So the skull is going to have material above it and below that's all connected together. To mitigate this, as you can see, I've basically made these little cutouts where those holes are, which should mean that when I convert this body and do a combined cut, that effectively I can just delete that top piece of material on the pillar and remove it, leaving a nicely perfectly contoured surface for the skull to sit on. You'll see what I mean in a minute. And here I am converting the mesh into a solid body. I'm doing combined cut here, and this means that the section of skull is being used as a very specifically shaped knife to remove the material in the shape of the section of skull. But unfortunately it's slightly still connected together by that tiny little point. Just by clicking that surface it's connected and hitting delete, Fusion is good at deleting that body. You can see I've got a floating region here as well, but again we can just remove that from the equation, and now you'll see that that pillar has a perfect negative impression of that skull surface, and this is great because effectively now we've got a perfect tailored surface for that skull to sit on. Just to make sure everything's locked in nicely for when I actually put the real life skull on the stand, I'm just roughly copying these contours and then adding some upstanding sections that are going to go into the holes in the skull. And this, as I say, just means that when everything's sat in place, it should be locked on quite nicely, but it also can be removed fairly easily as well. Importing the file into Bamboo Studio to slice the model up, I'm increasing the walls and the infill to make sure especially that that long rod is quite dense, meaning that there's a lot of surface area between each layer, meaning it should stay quite strong. Adding a bit of context to the whole thing, I decided to edit the design just before I printed it to include a nameplate plaque, which includes the year that he was born and the year that he died. I printed the plaque using Bamboo Labs multi-material printing capabilities, printing the black and white colours all in one print, which is super convenient for an application like this. If you made it to the end of the video, it's a big thank you for watching, and if you enjoyed, please consider subscribing and checking out the other videos on my channel. See you in the next one.